Okay, so we're still in our course, Introduction to Engineering. We discussed last time the design process steps. We said first you need to define the problem to be solved. Then you need to collect your data about the problem, and you need to understand why the problem happened in the first place. And we said as well, you need to identify the solution constraints and criteria. And moving again after that, you need to develop alternative solution in case you need them. And based on your criteria and constraints, you need to select the solution you want to go with, like solution A, solution B, solution C, and so on. And eventually, you need to communicate and document your results. So you need to communicate your results with your team, if you have a team, or with your upper management, or with the community, in case the problem is a community related. Then you document, as we mentioned before, when you're solving a bigger problem, then you need to make sure you're documenting that so that all the teams are aware of what you did. Are you guys good with that? Okay, so the first design process steps is about a problem that we have. But in many cases, we have a problem in the real life. So it's like you are designing some solution for that problem, so that you'll be able to provide a new product to the community or to a certain group of people where they have a problem that they experience. It could be the whole humanity. So the design process will be the same, but a little bit different. So in design process here, we're talking about if you are designing towards a future product, then if you have a future product, first you need to recognize the problem. Let's say somebody having a problem that his car doesn't go as fast as it should be, let's say, then you need to find a solution for that. Not necessarily that product is in the market, it could be a product that's not there. Like there's a need, but there's no product. Then you're trying to create a new product to solve that problem. So first you recognize the problem. That means you identify the needs for a product or service. Then you define the problem, so you fully understand the problem in this case. And the third one is you collect your data or you do your research. So it's basically similar to the first steps we learned, but it's a little different because you're talking about a product. Like somebody is having a problem, you're going to create a product or a service to solve that problem. Now, when you collect the data, you need to ask yourself, is this product already exist? Like somebody complaining, as we mentioned before, the steering wheel overheated. Then is there a product that makes the steering wheel cool down? Then can we improve the current product to meet the customer's need? So if already there is a product in the market, then can we improve that so that it will include the problem that the customer is mentioning in this case? And we discussed before that customer is an important factor in the design process. That's where he comes in collecting your data, identifying the problem, or even calling out the problem. Customer is always there. Then we do the concept of your solution. So we find ways so that we can solve the problem. Then we can come up with a solution concept. At this stage, let's say you want to design a product, then you are sketching down how your product will look like, what kind of properties does it have, and all that details. Then you identify as well in step number 4, the components of the problem. Like the problem is you're designing, let's say, a new wireless mouse. Then you want to say, okay, should it be charging by itself? Should it be solar charged? Should it be battery powered? Should it be plugged in? All that details. So the components of your problem is important to be identified in the concept phase in step number 4. Then we move into step number 5 where we synthesize and evaluate. So in this case, usually we are performing calculations, we are running computer simulations, or we are deciding the type of material to be used in our proposed product. Step number 6, you do optimization and presentation. That's the step similar to communication that we had previously. So basically here you try to make your design look as best as possible. Let's say somebody wants to design a wireless mouse as big as a keyboard. Well, that works, but it doesn't work in the market. Like, you need to have it fit on the desk, be able to use it, be easy to carry around by students, by professors, by any other people, engineers, and so on. So you need to keep in mind in this step that the design needs to meet all the criteria and constraints. you can discuss about size, weight, strength, and cost. So you're not just only designing a solution within your design process, but you are trying to optimize your design to meet the needs as well as still make sense in the market. So those are the 6 steps. Any questions here? So it's a little bit, it's similar but different than the standard design process. But I want to mention here, when I was reading through the text, I said, oh, we focused like as if we have a product we want to improve, while in reality you could have, which is most cases, you have a problem, but there is no product for it. So you got to create a new product to solve that problem. That after that, or that would go after that to filing a patent or creating an invention, where all the inventions that you heard about could go through this process. Maybe it will skip some of them, but still, as a general rule, it goes through most of those steps to be able to deliver a product that will solve a problem. Of course, we have in the market products that are not useful. Maybe you can name some of the products that are not useful, but still they go through this process, but you need to make sure there is a need. Like when you start with step number 1, there is a need, there is a problem you're solving, so that your product will have the market and will have the customers needed for it. So think about products in the market that don't follow these steps, or let's say products that they're not very useful. Well, now from the processes that or the steps for the design process to create a new product, we mentioned optimization. If you want to look into optimization, we said like somebody designing a mouse, could be as big as a screen, could be in the size of a box or a case. Then, well, that needs to be optimized. Optimized means make it better in many ways, make it more efficient. It could be the mouse would hook up right away to the PC, like a Bluetooth mouse. That would be efficiency, like how fast you can, the ease of use. That's one way to optimize it. Second way to optimize it, the size. You want it to be as sleek, as thin as possible, as much as the technology inside of it can be encapsulated. Optimization as well could be cost. I want it to be as cheap as possible while still durable and make sense, and the customers will be attracted to it. What else you think you can optimize for any product? I would say weight, cost, size, type of material used, ease of use. What else?
I would definitely say durability.
Durability.
What you make it out of.
Right, like you make a product, then durable means he can survive longer, he can worth your money, so that kind of thing. So firstly you have initial design. Let's say a mouse look like a box. Then now you perform analysis. You can see, can I do that? You do your analysis either through maybe PC, computer simulation, or it could be your analysis in calculations. Maybe you are calculating the current, calculating how much battery he needs. He needs a 9-volt battery or 3 volts battery and so on. Maybe I can just hook it up and have internal charging battery that's lithium ion based, then it will be thinner. And that kind of thing. So you do your analysis. In terms of design, you do sketches, you do calculations, you do all the analysis needed to be able to see if your initial design makes sense or need refinement. Now you have a result. After that, you evaluate your results of analysis. So you had, let's say, I don't know, the durability, you took it to the lab through your analysis. You took it to the lab and you did some testings, or you let your friend use it for a month. Then he said, hey, it broke down, or there's a kind of a clunky sound inside of it, or it doesn't look nice. Maybe you suggested for a girl, what do you think about it? She said, well, that's not girly at all. Then you lost your female customers and so on. So you evaluate your results. Now you can say, can the design be improved? If it can be improved, then yes, I go back to perform analysis. How I can improve that design through size, or through cost, or through analysis, or through durability, or let's say how long it can stay with one charge or with one battery, and all of that. So optimization, making things better, smaller, cheaper, more durable. That's how you think about the word optimization in the engineering team, or in the engineering field. Now you ask yourself again, you go back through the process, can the design be improved? No, then that's my final design. I think that's the best and greatest. As you always hear in the marketing for phones and electronics, like the next big thing, like they couldn't do better than that. Mm-hmm. Of course, surprisingly enough, 3 or 5 months later, then they have a new device. I don't know how. But yeah, like the next big thing means they did their optimization, and this is the next big thing. That's the top notch, especially if it's a flagship product. That's the top notch that they could do for this year. Now let's have a real world problem, and you reflect the product design process that we mentioned today, and try to put it into the boxes of the process. Now this is a real problem. I was thinking about it personally before, like in other states, but now we are reflecting in Georgia. So the young generation in Georgia is complaining that few gyms are available, like to do practices and stuff. So wherever they're living, mostly there's not much gyms available. And as well, many leaving the gym routine because they say there's low motivation. Like, I'm sitting like a rat on the treadmill, then so what? I'm just looking at the wall. There is no motivation. In the same time, the older generation is saying, they're complaining that there is a high cost of labor to work around the house in the US. Like, you hire somebody to do cutting the grass, or maybe just cleaning around the debris around your home. Then people are complaining, well, it's too expensive for them because not everybody from the older generation is doing well financially that they can afford it. Could be hypothetical, could be true. Now, how are we gonna solve these two problems by coming up with a new solution? I would like to hear from you, what's your thinking process? Now, I was just trying to cut the time. So the thing is, I was proposing that let's come up with an app where you can sign up to the app. You want to do exercises, then your neighborhood will be posting as well on their side that they have boxes in front of the house, they want to move it to the next side, or they want to cut their grass, or they want to clean around the house. Then you're willing to help the community, you're open to that, and you feel safe. It's your neighborhood, let's see your street. And so you cut the grass while he's happy, he didn't hire anybody. Of course, you can't sustain it. To be realistic, you can't sustain it. There is times where he gotta hire somebody to do that for him, because you can't always find somebody who wanna exercise. Yeah. Otherwise, you're abusing him, We found, let's say we talked about the solution a little bit. So it's an app where it connects between the people who need to work around their house, they can't financially or, physically. And there's young guys who are full of power, full of energy. They gotta release that power somewhere without being unmotivated. Then the neighbor said, "You're not motivated? Sure, I got the motivation for you."
Turning music on for you.
Now, first recognize the problem. What is the problem here? Now we're thinking in design process for a product. Now we are, let's say, having a company called XYZ. You are the engineering team, or let's say the engineering leaders, and we're saying, hey guys, we gotta solve this problem. And it's an opportunity where we can make some money as well, So let's create an app. Okay, then what are we gonna do? What is the problem exactly? You tell me. So the problem here is, as we mentioned, younger generation losing motivation to stay in the gym. As well, some of them are too far from the gym. Let's say 10 minutes is considered far because you can run in that 10 minutes and no need to go to the gym. Well, there is security and safety issues as well. The other problem is the older generation, they have a lot of debris around their house. There is work in the yard and stuff. I don't recommend to have anything inside the house, then you have more bigger problems. But the problem is, there's older generation who have debris around their home, younger generation having power or having energy. They want to release it and do some efforts. So you connect the two together, so that's the problem we have. It's like two problems in one. Now, if you want to define the problem in more details, the older generation, let's say we did an analysis, we go to the internet, we did an analysis, and we said people beyond 65 years old, let's say only 30% of them are wealthy, 70% are poor or under middle class, and so on. Then you can analyze in the state of Georgia how many are experiencing some financial problems. That's one way to define one side of the problem, which is the side of the elder people need help. The second problem is we can do an analysis how many people left the gym, let's say under 1 month. They go to the gym and they never continued. Then maybe you have some kind of study that somebody did and they say, well, we lost motivation. So now you are defining the problem, make sure it is an actual problem, not just something that you think it's happening. Now let's collect the data or do the research. What you're gonna do here? Part of the research, good to know that market research is part of the research. Like as you mentioned, making sure the young generation is willing to work that for free and they're feeling safe and feeling they have the power to do that. Then at the same time, make sure the older generation are comfortable that somebody random would come into their yard and supposedly to clean the yard or cut the grass and so on. So that's for collecting data. You can collect as much data as you want. You can see how many apps in the market are doing that. So let's go ahead now to Google and see, is there an app doing similar thing? So that's part of our collecting data or research. So doing the market research, you can go ahead and tell me whenever you're ready. So now I want to see, is this app available in the market or no? If I couldn't find anything exactly doing that, that's a good sign. That means I'm into an app that could be a new app. Now, is it like, would it be a successful app or no? How I would do that? I would look into similar close enough apps and look at them. See, is that like a website-based kind of service or is it an app? That's first thing. Like I would say, so similar or I would say similar apps. So I would look into similar ideas. Then I would say, in this case, our idea is app. Then I would say, okay, do we have other ideas which is app-based or a website-based? So it could be either or. So there's similar, let's say have solution, and it is a website, like website-based. That's one. Then you can say we have similar app for older people. It's like this app will do only half of the problem solved. It is a website based firstly, but these days there is 60-70% of users are using phone. So let's say somebody else has the exact same idea and it's a website in this case, then you can do an app for it or something a little different but similar, and you will be having an advantage beyond him by being in the market, in the right place. Now we know there is no app doing that. Then we can go to the similar apps and see how many people in the iOS store, let's say in the App Store or in the Android store, how many installed those similar apps. We want to see those apps would be, if we spend the money on this app, would it be successful or no? We can't tell until we launch it, but we can kind of estimate before we launch it by going to similar apps and see how they're doing. If the app been released 3 years ago and there's only 1,000 downloads, then that means it's a failure app. No need to spend your time doing a similar app because it's gonna fail, right? Anyway, now let's go to step number 4, which is conceptualize. So we said we have a gym serve app that will serve the older and younger generation, connect them together. The older generation need people to do some work for them, while the younger generation looking for stuff to do so that it will replace the gym and having motivation close by from where they live. Now we have step number 4, conceptualize. So we need now to define the concept. So we said in this case it's not a product, it's an app. To define the concept of the app, still in the physical product, you draw sketches. Let's say if you have a mouse, you will draw a side view sketch of the mouse. Maybe you will do a top view sketch of the mouse, and so on. So you conceptualize, doing a handwritten or through computer softwares and so on. to be able to change the idea from your brain into reality, or let's say as close as possible to 3D design, like getting one step closer to make that happen. Now in our case, it's not a hardware, it's an app. You know, the app will be running on a phone screen, right? So we start by creating the concept for our phone screens. Now the first screen in our concept would be, so this is your phone. Now inside the screen, to serve the purpose of your app, you gotta start to develop the concept. Help me here. So first you need maybe login and registration, right? So login, exactly how you see the buttons on your phone. Then you would say, okay, the second screen would be, now I logged in or I registered. Now there should be two screens, or let's say you choose, are you young generation or old generation before you go to the third one. You need to decide what you're gonna show him. So in a certain elegant way, you can say older or younger generation. So he would choose login, then he would choose, okay, I'm an older generation. Then after that, you could say, okay, if you click on older generation, you're gonna create another screen for your app. For the older generation, let's say you have a map. So it's a map-based app. Let's say you have here Douglas, and you have here Waycross. Then let's assume this customer is in Douglas area. You give him a circle for Douglas. Then this older generation can post a request. So you can give him here an option. Post a request, or post a job, or any way you would define it. For younger generation, let's say here, so you went down. By the way, if you ever looked at how the schematics of the apps, how the apps are designed in the concept phase, this is exactly how it looked like. So in case you decide one day to go through an app and how to design it, you're going to give the designer something similar to this to be able to make it a reality for you. So for younger generation, he will see a map as well. In that map, he will see job here. Let's say his location is here. You're going to see job here, job here, job here. Now let's say he clicked on job 1, which is close to him. You're going to give him another screen. That screen would be, let's say time, what time it is. Let's say exact location or address. Then you can say accept. Design team should determine with the customer the expectations of the solution. You always need to let the customer know or be informed about the design changes. You know, as you're moving with the design, you always change stuff. So make sure if it's a customer product, make sure he's informed. We're talking about this case when the customer asks you to do something, then you keep him informed. If you are designing a new invention, then you can ask the customer, what if we do this, what if we do that? But it's more applicable if you have a product that the customer told you, hey, design for me a wireless mouse that looks nice and elegant and neat and fast and stay long before charging and so on. Customer and designer need to modify requirements sometimes to meet the deadline. Like customer can't be hard-headed, the engineer can't be hard-headed. You gotta always be flexible and work around to find a solution for the current problem. Now I would say this is the satisfaction graph, or like design versus customer graph. So now the customer asks something, it's a basic design. Like the requirements are here, you have here degree of achievement to the right, up customer satisfaction. You've gotta find the sweet spot between achieving what the customer wants in requirements and achieve the customer satisfaction. Now between the basic requirements or the basic things that you did as an engineer and the exciting stuff, like you let the product do exciting stuff and he's like, wow, nice product. There is a performance related, related balance that makes sure the product is meeting requirements, the basic ones, and exceeds. When he meets the basic requirements and a little bit more, that means the product is performance related product. Like, it's a good product, it meets requirements, everybody's happy. Well, sometimes engineers realize, hey, your wireless mouse, I can make it charge by the solar power or by the light in the room. Then the customer, he didn't ask for it, but you gave it to him kind of bonus point or for free. This way, the customer will be more excited about your design and will be more satisfied and happy from your service. So keep that graph in mind. Any questions here? Now let's have a quick example. So you have electric powered grill. What is the basic requirements? So this is a breakdown of an actual patent for electric powered grill. I forgot what year is it, I believe it was 2014. Now, he needs the grill, what the customer needs, basic requirements, he needs design and manufacture electric powered grill. He's very generalized. Now, the performance requirements, like requirements related to performance, you need to have the option to have a cooking time. You need to have cooking effectiveness, like he gives the right heat and he's able to be able to cook stuff. Then it's easy to use it, easy to clean. So those are performance. You know, the basic, you need just a powered, electric powered grill, but you need to make sure by default he's cooking effectively, easy to use, easy to clean. You can choose the cooking time needed and program it and so on. There is exciting requirements you can add to it. Those requirements are not requested by customer, but they are still useful. Then let's say you need to be able to program a cooking cycle. The customer didn't ask for it, but you give him the option, I can program the cooking cycle, like start hot, then chill down a little bit, then hot again, and so on. You can ask as well, or you can let the device do varying cooking temperature during the cooking process, as we mentioned, so that the cooking will be more perfect. And let's say in this case, your design would be beyond expectations of the customer. Now, the nature of the engineering design. Engineering design is a cognitive process, which means first you need a broad knowledge base, you need to be intelligent in using information, and you need to have logical thinking in the same time. Now, what is cognitive process? 1950, Benjamin Bloom developed a classification scheme to be able to identify the cognitive ability. He called it that time Bloom's taxonomy. It is basically showing you, as the graph is showing you, it will test for knowledge, then comprehension, application, analysis, synthesis, and evaluation. It's a way of evaluating somebody's smartness, let's say, or the logic thinking of somebody. So in engineering, they use that to be able to identify the process of design thinking. Knowledge, you need to be able to recall information, facts, and theories. Comprehension, you need to be able to make sense and understand the material. Application, you need to be able to use knowledge and comprehension in solving new situations. Like you're using your old knowledge to create new solutions. That's where engineering starts. Then analysis, you need to break the learned material into components, parts, and understand the whole structure of it. For synthesis, you need to diverge your thinking by producing new insights and discoveries that were not part of your original information. So you're able to create new inventions, new products, new services that the humanity didn't know before. Eventually, you evaluate, you'll be able to have critical thinking, critical judgment, evaluate the available knowledge and ideas. You can see here, we start with the basic one, knowledge, then comprehension, being able to digest that knowledge, then applying the knowledge by combining knowledge and comprehension into application, analyzing the knowledge you have, and trying to produce new ideas and new thinking and new concepts. Now, design opportunities and future challenges. Of course, you heard that over and over again in all places. We have challenges as humanity in energy, environment, and infrastructure. As an engineer, future engineer, we expect you to help us find other resources or other sources of energy and enhance the current solution, like solar power, wind power, how we're going to harness it better. You know, solar power is only 20-25% efficient, so you've got to make that more efficient, come up with new solutions and ideas. For environment, we want to make sure we have the ease of cleanup, the debris and the leftovers need to comply with all the national and world orders and laws. And conservation, make sure we're using the environment wisely and not be able to degrade it as moving forward. Then we need to prevent the pollution as they're doing today, making cars cleaner and making the emission on lower levels. For infrastructure, we have transportation, railroads, highways. We need to care about the waste disposal, come up with new ways to dispose the waste and better ways. In water distribution, as we mentioned before, some of water pipes and water transportation is defected in many places, worldwide and in the country as well. So come up with solutions how to make those water distribution lines more efficient and having less problems. Now the Engineers Grant Challenge, that's been reported recently. We need to make the solar energy more efficient and economical to make it and efficient in its outcomes. Then you need to provide energy from fusion, develop carbon sequestration methods, manage the nitrogen cycle, try to provide cleaner water, restore and improve urban infrastructure, advance health informatics, reverse engineer the brain if you can, and enhance virtual reality, secure cyberspace, which is the internet, and advance personalized learning. Any questions? The concept of reverse engineering, we have a couple of minutes, 2 minutes. Who knows about reverse engineering?
Like taking it apart.
Like,
Just breaking it down.
I tell you, I have this new product. It came from, I don't know, it fell with an asteroid, and I don't know what it is. I know it's a device, somebody made it. Then we said, okay, let's reverse engineer it.
You gotta break it down to its constituent parts.
It's like, yeah, you're always in the design process. In the design process, you start. So in the design process, you start from the idea going up to come up with a product. Sometimes you have the product that you didn't have access to, or how it's made, or it's not been communicated, no documentation anywhere. So how to be able to come up with it or with something similar, that's what's called reverse engineering. I gave you this mouse, you never saw it before, you know what it is. You tear it down in parts, try to understand what each component do. Okay, this is a battery, this is a cover, this is a roller, and so on. Then you come up with the concepts and how things work together to be able to replicate it and redo it on your own. So when we say brain reverse engineering, we know how brain develop biologically, but we don't know how to replicate it until today. The most advanced computers still not able to replicate the brain. So reverse engineering it means learning more about it, to break it down into pieces whenever we can.